Good evening, everyone. A very good evening to all of you, bacho. We are live. We are back on ExamDost. We are back for the course on power electronics. Okay. Now, what we are going to do today, we are going to wind up the single phase rectifier, and then we are going to start with the three phase rectifier. सिंगल फेज रेक्टिफायर खत्म करके आज हम लोग थ्री फेज रेक्टिफायर स्टार्ट करने वाले हैं. So get ready everyone, we are going to start three-phase rectifier. But before doing that, let us review what we covered in the previous lecture. I taught you full wave converter, both midpoint and the bridge type. So we took a highly inductive load and constant load current. Average value was 2 Vm by pi cos alpha, PIV was 2 Vm. But in a bridge converter, we solved the problem of high PIV. The average output remained 2 Vm by pi cos alpha, but PIV became Vm, and we did not need any center tap transformer. Okay, so average output becomes 2 Vm by pi cos alpha. Supply RMS is I naught, fundamental RMS 2 root 2 by pi I naught. Distortion factor was 2 root 2 by pi, FDF was cos alpha, input power factor was G into FDF, and THD was 48.4%. For semi-converter, the average output was Vm by pi 1 plus cos alpha. So semi-converter has a freewheeling diode which provides the path for the flow of current when V0 is negative for the inductive load. Okay. So thyristor conduction angle and the diode conduction angle is pi for the case of symmetrical. Okay. And beta, this is the conduction angle for asymmetrical. And this is what happens when you have a full converter plus freewheeling diode. Okay, beta? These are your conduction angles. So average output voltage is this. The RMS source current I0 by pi root pi minus alpha by pi. Fundamental RMS 2 root 2 by pi I0 cos alpha by 2. FDF cos alpha by 2. Distortion factor fundamental by total RMS. Input power factor is G into FDF. What is the advantage of a semi converter? It has a better power factor than a full converter. ठीक है, क्या क्या याद होना चाहिए पूरे सब्जेक्ट में? बेटा ऐसे पूरे सब्जेक्ट का समरी कौन दे सकता है कि क्या क्या याद होना चाहिए? ठीक है, अभी रेक्टिफायर चल रहा है तो रेक्टिफायर में मैं आपको बता सकता हूं कि रेक्टिफायर में अगर रटना ही है तो आप फुल कन्वर्टर और सेमी कन्वर्टर के फॉर्मूलाज याद कीजिए. ठीक है, और सिंगल फेज हाफ वेव में आप लोड के नेचर के अनुसार ऑपरेशन समझ के सॉल्व कीजिए. आप बेसिक से बनाइए विद द हेल्प ऑफ द ऑपरेशन. दैट इन विच रीजन डज द कंडक्शन हैपेंस, व्हाट इज द स्टार्टिंग एंड द एंडिंग एंगल ऑफ कंडक्शन. इस तरीके से आपको सॉल्व करना है. इतना मैं आपको बता सकता हूं, बट ओवरऑल सब्जेक्ट में तो कैसे आप करोगे बताओ? चलिए ठीक है, लेट्स कंटिन्यू बेटा. So in the previous lecture beta we saw there were question regarding shorting and opening of any thyristor or diode in a rectifier. So suppose I short circuit or open circuit one SCR in a single phase full converter. Okay. So suppose beta, suppose let us assume that T4 is short circuit. Sorry, I am assuming T3 is short circuit. Okay, suppose T3 is short. If T3 is short, beta, T3 is permanently on. Now you know from one group, one device has to conduct. आपको ये पता है ना, दो में से एक डिवाइस को कंडक्ट करना होता है एक ग्रुप में से. Okay. So if T3 is permanently on, मेरे बच्चों, T3 is permanently on, that means T1 cannot turn on. T1 ऑन नहीं होगा. हाँ, कल ऑफ था क्लास, और जेके पीएससी के लिए बेटा विद्युत एजेई बैच ले सकते हो. Now T3 is permanently on, so T1 will be permanently off. Now T4 will be on from alpha pi plus alpha to 2 pi plus alpha. So V0 will be minus Vs, Is will be minus I0. T2 will be on from alpha to pi plus alpha. So when T3, T2 are conducting, V0 will be 0, Is will be 0. V0 will be 0, Is will be 0. देखो ऊपर से T3 ऑन हो गया, परमानेंट शॉर्ट सर्किट हो गया, तो अब T1 की जरूरत ही नहीं पड़ेगी, T1 आ ही नहीं सकता कंडक्शन में. तो आपको T3 के साथ ही इन दोनों का कंडक्शन लेना है और V0 जज करना है. तो फ्रॉम अल्फा टू पाई प्लस अल्फा V0 इज 0, फ्रॉम पाई प्लस अल्फा टू 2 पाई प्लस अल्फा माइनस Vs. तो देखिए फ्रॉम अल्फा टू पाई प्लस अल्फा 0, पाई प्लस अल्फा टू 2 पाई प्लस अल्फा इट इज माइनस Vs. Minus Vs means we are following this blue curve. Okay, is that clear, beta? So now when you take the average comes out as Vm by pi cos alpha. What about Is? Alpha to pi plus alpha 0, pi plus alpha to 2 pi plus alpha minus I0. So average is minus I0 by 2. RMS will be I0 by root 2. And I0 will be V0 minus E by R. I0 कितना आ गया? V0 minus E by R. हाँ, लेवल ऑफ क्वेश्चन AJE लेवल का ही रहेगा सेल में. Now suppose T1 is short circuit. If T1 is short circuit, beta, T3 cannot turn on because again in one group of devices only one thyristor will conduct. So if T1 is short circuit, T3 cannot be on. T1 short circuit हुआ तो T3 कभी भी on नहीं हो पाएगा. Now from alpha to pi plus alpha T1 T2 conduct. So V0 is Vs, Is is I0. Pi plus alpha to 2 pi plus alpha T1 T4 will conduct. So V0 will be 0, Is will be 0. V0 will be 0, Is will be 0. If T1 is short circuit, T3 is off. So like this you have to think, beta. Alpha to pi plus alpha Vs, pi plus alpha to 2 pi plus alpha 0. ठीक है? Now Is alpha to pi plus alpha it is I0, pi plus alpha to 2 pi plus alpha it is 0. So average current will be I0 by 2, RMS will be I0 by root 2 and average value is Vm by pi cos alpha. Next, if T3 is open, T1 has to be permanently on. So it is same as the previous case. ठीक है, अगर T3 को ओपन कर दिया तो T1 को परमानेंट ऑन रहना पड़ेगा. So this is same as previous case. Similarly, if T1 is open circuit, बेटा ये तो सारा सेम आ गया. Similarly, if T1 is open circuit, T3 has to be permanent on, same as first case. Okay, this is same as first case. Okay, beta, clear हुआ? So in case of R load, beta, in case of R load, you do not have to take the conduction beyond pi. तो आप पाई प्लस अल्फा तक ना जाके अल्फा से पाई तक ही कंडक्ट कर लीजिए. So if T3 is open or T1 is short circuited, T1, T2 will conduct from alpha to pi. It is same as a half wave rectifier. If T1 is open, T3 is short, T3, T4 will conduct from pi plus alpha to 2 pi. It will work like a half wave rectifier. There is no mandate, there is no compulsion to conduct in both the half cycle. जब रेजिस्टिव लोड है तो ऐसा कोई आपके लिए कंपलसरी नहीं है कि सर दोनों हाफ साइकिल में कंडक्शन आना चाहिए. एक ही हाफ साइकिल में कंडक्शन आएगा, हाफ वेव रेक्टिफायर की तरह बिहेव करेगा. तो एवरेज आउटपुट आएगा Vm by 2 pi 1 plus cos alpha. RMS 1 by 4 pi pi minus alpha half sin 2 alpha. If it is a R load, ठीक है, दोनों हाफ साइकिल में कंडक्शन नहीं आएगा. Is that clear? Now beta, suppose it is a semi converter. In case of semi converter, remember the conduction of the diodes. Now if T3 is short circuit, T1 has to be permanently off. अगर T3 शॉर्ट सर्किट हुआ तो T1 परमानेंट ऑफ हो जाएगा. Now T3 D2 will conduct from 0 to pi. V0 will be V0 will be 0 and IS will be 0. T3 D4 will conduct from pi to 2 pi. V0 is minus Vs, Is is minus I0 from pi to 2. Okay. So see, 0 to pi 0, pi to 2 pi minus Vs, 0 to pi 0. And Is is minus I0 from pi to 2 pi, 0 to pi 0, 2 pi to 3 pi 0. So V average is Vm by pi, Is average minus I0 by 2, RMS I0 by root 2. If T3 is open, beta, if T3 is open, T1 has to be permanently on because load is highly inductive. Okay. If the load was resistive, there is no problem of remaining permanent on. अगर लोड आपका रेजिस्टिव होता है ना तो ये परमानेंट ऑन वाली सिचुएशन नहीं आती. नाउ बेटा D2 will conduct from 0 to pi, D4 pi to 2 pi. So T1 D2 from 0 to pi, V0 Vs, Is I0, T1 D4 same branch, pi to 2 pi, so V0 0 and Is will be 0. So 0 to pi V0 is Vs, Is is I0, pi to 2 pi 0, Is is 0. So average Vm by pi, average I0 by 2, RMS I0 by root 2. क्लियर हुआ? क्लियर हुआ बेटा? ये कैसे थॉट प्रोसेस बनाना है ओपन सर्किट शॉर्ट सर्किट का, बोलिए. How to think about opening and shorting of a thyristor in a full converter and semi converter. Now, what you were asking me, which formulas you have to memorize? See this. देखो फर्स्ट थिंग, now make the V0 half replace cos alpha by 1 plus cos alpha. V0 को आधा करके cos alpha की जगह 1 plus cos alpha कर दो. Then supply RMS I0 fundamental RMS I0 into 2 root 2 by pi. Here same beta, but with cos alpha by 2. ठीक है, इन सेमी कन्वर्टर यू मल्टीप्लाई इट विथ cos अल्फा बाय 2. Then distortion factor, which is fundamental RMS by total RMS. Now here it will depend on alpha. Here you will get constant value of G, but here it will depend on alpha. Okay. For RLE load, if the load current is continuous, beta, it will behave like a RL load. ठीक है, not like a semi converter. फुल कन्वर्टर की तरह ही बिहेव करेगा. ठीक है, उसमें सेमी का कोई रोल नहीं है. नाउ THD 1/G square minus 1. Here again it will depend on alpha. Put power factor G into FDF. Okay. Here it will depend on alpha. And what about FDF? फुल कन्वर्टर तो फुल अल्फा, सेमी कन्वर्टर तो अल्फा बाय 2. Okay. Next, if you talk about thyristor and the diode conduction angle, both are pi. Here also both are pi for symmetrical. Well, full converter plus freezing diode. Okay, that is the value. Clear हुआ भाई? Is this clear to everybody? बताओ. So these are the formulas, beta. Rest so you have to remember the basic variation of load. How the changing of load impacts the output. So now, beta, now I will move on to three phase. Let us start. So beta, now in case of a three-phase half-wave rectifier, we have three thyristors. One thyristor is connected in each phase. हमारे पास तीन thyristor होते हैं हर phase में एक एक thyristor. Now because their cathodes are connected to each other, it is called common cathode. Okay. Now if it is a R load does not allow negative V naught, but if it is a highly inductive load, for highly inductive load, conduction goes on continuously. Now, what is the rule of common cathode? The common cathode connection says the SCR having the maximum value at the input or SCR with the maximum value of voltage at the anode will become forward biased. जिस किसी SCR का maximum voltage anode पे लगा होगा वही forward bias होगा. Now, based on the three phase voltages, beta, AN is maximum from 30 to 150, BN is maximum from 150 to 270, CN is maximum from 270 to 390. माने each of the three voltages are highest for 120 degree, and in that 120 degree the thyristor will become forward biased. Now the reference that I take is the AN, which is VMP sin omega t. VMP is the maximum value of the phase voltage. VMP माने M माने maximum, P माने phase. Now suppose suppose beta I take alpha equal to 60 degree, alpha equal to 60. So now the conduction of thyristor will start alpha angle after the forward biasing. So VAN will start at 30 plus alpha. EN will start at 150 plus alpha. And CN will start at 270 plus alpha. Okay. That is their starting angles. So if alpha is 60, AN will start at 90, BN at 210, CN at 330. So AN will start at 90. Ideally, it should continue till 210 when BN comes. AN 90 पे शुरू हो रहा है, कायदे से इसे 210 डिग्री तक जाना चाहिए जब BN आता है. But it is a R load, so it cannot go beyond 180. It will stop at 180. But BN will come from 210 till 300. Again, cannot become negative, stays 0. Then CN. So waveform is clipped. That means you are getting discontinuous conduction. What if alpha is 30? What if alpha is 30? So then AN will go from 60 degree. So ideally it should go from 60 to 180 for 120 degree. Here beta each voltage should come for 120 degree. But make sure in a R load the output does not become negative. यहाँ तीनों वोल्टेज 120 के लिए आनी चाहिए. बस ये ध्यान रखिएगा आर लोड में नेगेटिव ना जाएं. तो AN will start at 30 plus alpha, that is 60, till 150 plus alpha, that is 180. PN at 180 to 300, CN at 300 to 420. So 60 to 180, it does not become negative. Then 180 to 300, then 300 to 420. 420 माने 60 degree. Now clearly you can see in one cycle of input, there are 3 pulses coming. So it is called as a 3-pulse converter. And here output is touching 0. So it is the boundary between continuous and discontinuous conduction. Here output remains at 0 for some duration. This is discontinuous conduction. So what is continuous? When output never becomes 0. What is discontinuous? When output stays at 0 for some duration. And what is boundary? When output just touches 0, it does not stay at 0. Now what if alpha is 60 for inductive load? In inductive load beta, you don't have to worry about the negative output. AN will conduct from 30 plus alpha to 150 plus alpha, that is 90 to 210. So this portion where you were getting 0, now you will get the negative value. So this is your AN. So you are getting negative output in case of highly inductive load. What if alpha is 120? If alpha is 90, then it will start at 30 plus alpha, 120. Should continue till 150 plus alpha, 240. ये 120 से 240 जाना चाहिए, but this is sine. Sine after 180 is negative. So for R load, you cannot go above 180. So you will start at 120, but you will end at 180. This portion you are not going to cover. आप ये 180 से 240 वाली जर्नी नहीं करेंगे. You are not going to take this path, है ना? Rather, you will make the output 0. Then BN will come. It should come from 240 to 360, but it will stop at 300. It will not take this path. No. Rather than this, it will make the output 0. Okay? Similarly, the third waveform will be CN. Okay? समझ में आया? So you get discontinuous conduction whenever alpha is greater than 30. So these are the things you need to remember beta. Reference is the VMP sin omega t. where VMP is the peak value of phase voltage. It should conduct from 30 plus alpha to 150 plus alpha. But if alpha is greater than 30, we get discontinuous conduction in a R load. So my conduction will stop at 180. मेरा कंडक्शन कहां से कहां तक जाएगा तब 180 तक. नेगेटिव ऑपरेशन आर लोड में नहीं करना. मैंने आर लोड के बारे में क्या पढ़ा रखा है कि वी नॉट कैन नेवर बिकम नेगेटिव. ठीक है. So for alpha greater than 30 beta, I will get discontinuous conduction for R load and the limit will be 30 plus alpha to 180. We just have to remember the limit of the reference waveform. Reference waveform is VAN. For alpha less than 30, for resistive load it is continuous. So continuous conduction you will integrate from 30 plus alpha to 150 plus alpha. Okay. So you get 3 VML by 2 pi cos alpha. Okay. 3 VML by 2 pi cos alpha. VML is the peak line voltage. So continuous alpha less than 30 for R load, for all alpha in highly inductive load. Highly inductive में कोई भी अल्फा ले लो, R load में अल्फा less than 30 it will be continuous. For RMS also same limit. Period is 2 pi by 3. Why? It is a 3 pulse converter. So 3 pulses in a interval of 2 pi माने 1 pulse is 2 pi by 3. 3 pulse अगर 2 pi में आ रही हैं तो एक pulse हुई 2 pi by 3. So the integration will be from 30 plus alpha to 150 plus alpha. This continuous when alpha is more than 30 for R load. The upper limit instead of 150 plus alpha becomes 180. Upper limit instead of 150 plus alpha becomes 180. Logic समझ में आया? So PIV across any thyristor is the maximum line voltage. Thyristor conduction angle is 120 degree for continuous 150 plus alpha minus 30 plus alpha. Okay. And if alpha is 90 beta, for alpha 90 in a highly inductive load, I am getting continuous conduction. ठीक है. V0 does not remain at 0. बात समझ में आ गई? 0 पे नहीं रुक रहा है. चलिए. Is this clear? Now I come to a full wave uncontrolled rectifier. In a full wave beta, there are 3 diodes connected in the common cathode configuration. The lower 3 diodes are connected in common anode configuration. Now, what is the purpose of common cathode beta? Common cathode always transfers the maximum voltage at the output. Okay. Common cathode is basically transferring maximum voltage at the output, while common anode, the common anode will transfer maximum negative voltage. Common anode क्या करेगा? Maximum negative voltage को pass करेगा, and as a result, the output will be the maximum line to line voltage. Common cathode जो ऊपर वाला है बेटा, it passes the maximum phase voltage to the output. The lower common anode passes the most negative phase voltage. So the voltage across the output is the maximum minus minimum, maximum line to line voltage. So that is why we take the reference as line voltage instead of phase. इसीलिए reference यहाँ पे line को मानते हैं. VML sin omega t. Now sin omega t is maximum at 90 and it is a 6 pulse converter. So pulse width will be 60. So you subtract 90 minus pulse width by 2, 90 plus pulse width by 2, you get the interval 60 to 120. In a half wave rectifier also beta, this is my reference. It is maximum at 90. It is a 3 pulse converter. 3 pulse माने pulse width is 120. Pulse width is 360 by 3, 120. So now 90 minus 120 by 2, 30 degree. 90 प्लस 120/2 150। तो ये जो साइन ओमेगा टी है बेटा, इसका इंटरवल निकालने का यही जुगाड़ है, दैट 90 माइनस पल्स विड्थ बाय 2 टिल 90 प्लस पल्स विड्थ बाय 2। समझ में आया जुगाड़? So here VAB will come at the output from 60 to 120. So from 60 to 120 you are getting VAB. Now you will repeat the same waveform 6 times. अब यही waveform को 6 बार repeat कर दीजिए. You will get a 6 pulse output. 6 pulse output. So CB comes from 0 to 60, AB 60 to 120, AC 120 to 180, BC 120 to 180 to 240, BA 240 to 300, CA 300 to 360. Okay, so that is how your output looks like. ठीक है, ये मेरा आउटपुट है. अगर आपको ये देखना है ना एक एक वेवफॉर्म कैसी दिखती है, मैं अलग अलग कलर से दिखा देता हूं. तो ये VAB है. Now the opposite of this is VBA. This is VBA. This is VBC. A. Then opposite of this is A. So that way beta I have 6 line voltages. Okay. Now whichever is the maximum line voltage highest among all the 6 will appear at the output. जो भी 6 में से सबसे ज्यादा है वही आउटपुट पे आएगा. Okay. So VML is the maximum line to line voltage. So average value is 3 VML by pi. For RMS, period is pi by 3 because it is 6 pulse. Integration from 60 to 180 VML square sine square omega t. But what if it is a controlled rectifier? Then all the voltages coming at the output are shifted by alpha. So VAB, rather than coming from 60 to 120, it will come from 60 plus alpha to 120 plus alpha. AB जो कि पहले 60 से 120 आ रहा था, अब वो 60 प्लस अल्फा से 120 प्लस अल्फा आएगा. ओके, 135 क्यों रखते हैं बेटा? ताकि हमें ये पता रहे ऑड नंबर माने ऊपर वाले थायरिस्टर और इवन नंबर वाले नीचे वाले थायरिस्टर. ठीक है, तो अगेन बेटा आई हैव द सेम 6 लाइन वोल्टेजेस. This is AB. Now AB, rather than coming from 60 to 120, it will come from 60 plus alpha to 120 plus alpha. And also remember beta that for the case of R load, you cannot let the output become negative. R load के लिए आउटपुट को नेगेटिव मत जाने देना. ठीक है, फॉर हाईली इंडक्टिव लोड तो आई विल कंडक्ट कॉन्टिन्यूअसली. ईच लाइन वोल्टेज विल कम फॉर 60 डिग्री. But for highly inductive load, we have to take care the output should never become negative. Just like in a half wave rectifier, we said na that the reference voltage which was sine omega t does not conduct beyond 180 degree. So these are my 6 line voltages. So now, when you talk about alpha equal to 30, then AB will go from 60 plus alpha to 120 plus alpha, that is 90 to 150. 90 to 150. So you just trace the graph of VAB and repeat that for 6 pulses. आप VAB को ट्रेस कर लीजिए और उसी को बेटा 6 बार ड्रॉ कर दीजिए, तो you will get the output. Now beta, whenever AB and AC are conducting, whenever AB and AC are conducting, it means one thing, that phase A is supplying current to the load. So current of A is I naught. But when the voltage is BA or CA, BA or CA, means A is the second subscript. It means beta A phase is carrying the current back to the source. So their current is minus I naught. Minus I naught आता है. Remember one thing, VXY माने current leaves the X terminals and comes back from the Y terminal. Current X से निकल के Y से वापस आता है. That is the meaning of VXY. So similarly, when you talk about AB or AC, current is actually leaving the A terminal. But when you talk about BA or CA, current is actually coming back from the A terminal. Current A वाले terminal से वापस आ रहा है. So that is how you draw the supply current. Okay. Now, the circuit turn off time, you have to memorize. You don't have to draw the waveform. Circuit turn off time is basically 240 minus alpha by omega. But do not forget to convert 240 minus alpha into radian. 240 minus alpha को भैया radian में convert कर लेना. So it will be 240 minus alpha by omega. That is your circuit turn off time. Now, if alpha is 60, then VAB conducting from 60 plus alpha to 120 plus alpha will go from 120 to 180. Okay, where alpha is 60. So AB will go from 120 to 180. Okay. Now, because you are going up to 180 degree, but you are not going negative, it is boundary between continuous and discontinuous. अगर 180 तक जा रहे हो यानी जीरो को टच कर रहे हो, तो it is boundary between continuous and discontinuous. Again, beta, whenever output is VAB or VAC, it means one thing, that current in A phase is I naught. ठीक है, current A phase का कितना है? I naught है. And when it is BA or CA, the current in A phase will be minus I naught. BA or CA, current in A phase will be minus I naught. Okay. Now, circuit turn off time is again 240 minus alpha by omega. Now, if alpha is 90, then 60 plus alpha will be 150. 120 plus alpha will be 210 degree. So, AB will conduct from 150 to 210. Okay, 150 to 210. Okay, this is how AB will look like. And again, when ABAC is there, A is I naught. BA and CA is there, it is minus I naught. Okay. Circuit turn off time, as soon as you go above 60 degree for alpha, alpha 60 के ऊपर जाता है, तो circuit turn off time becomes 180 minus alpha by omega, not 240 minus alpha by omega. But when you talk about alpha 90 for resistive load, You cannot have these negative peaks. R load does not allow negative portion in the V naught, so that negative portion will be clipped. Just a moment. हाँ जी, for R load beta, because V naught cannot be negative, the negative peaks will be clipped from the V naught. So here output VAB is VML sin omega t from 60 plus alpha to 120 plus alpha. Alpha 60 is the boundary between continuous and discontinuous for R load. For thyristor, conduction angle is 120. For one phase, it is 240. 120 positive, 120 negative. For continuous conduction, this is the average output 3 VML by pi cos alpha. For RMS, take 1 upon period. Integrate from 60 plus alpha to 120 plus alpha. Square of VAB. For alpha greater than 60, you get discontinuous conduction for R load. So integration from 60 plus alpha up to 180, not 120 plus alpha. Okay, up to 180. Circuit turn off time has two formula for alpha less than equal to 60, 240 minus alpha by omega, alpha greater than 60, 180 minus alpha by omega. Fundamental RMS same as single phase, one factor extra cos pi by 6. For supply RMS, conduction is for 240 out of 360, I naught root 2 by 3. Distortion factor fundamental by total RMS 3 by pi. Input power factor G into FDF. FDF is cos alpha. THD is 31%. If you connect a freewheeling diode across the load, it can only conduct if V naught becomes negative, which happens if alpha goes beyond 60. अगर अल्फा 60 के ऊपर जाता है तभी V नॉट नेगेटिव आता है. तो इट विल कंडक्ट फॉर द ड्यूरेशन अल्फा इज अबव 60. अल्फा 60 से कितना ऊपर गया उतने एंगल के लिए कंडक्ट करेगा, बिकॉज देर आर 6 पल्सेस, तो 6 टाइम्स. PIV इज VML. तो ये बेटा आप लोगों के लिए फॉर्मूला लिस्ट हो गई पूरी. ठीक है. फॉर हाफ वेव कंट्रोल्ड कन्वर्टर इट विल बी 3 VML by 2 pi. Okay, not VM. Is that clear? So that is the average fundamental RMS, total RMS, G, IPF, TC, gamma FD. चलिए, JK SSB का बेटा बच्चों से जितना बात करके समझ में आ रहा है, कट ऑफ शुड बी बिटवीन 70 एंड 80. जितना बच्चों का फीडबैक आया है उसके हिसाब से. पेपर के हिसाब से नहीं मैं बोल रहा हूं, पेपर इतना टफ नहीं था, लेकिन जैसा बच्चे करके आए हैं. तो 3 phase half wave converter has how many pulses? Come on everybody. How many pulses? It is a 3 pulse converter, correct? हाँ, इसको 6 pulse converter बोलते हैं निकेत भाई फुल वेव को. Why can't we start before 30? क्योंकि 30 पे फॉरवर्ड बायसिंग आ रही है. फॉरवर्ड बायसिंग तब आती है जब उसकी इनपुट वोल्टेज मैक्सिमम होती है. ठीक है, यानी बाकियों से ज्यादा. For 3 phase half wave converter with highly inductive load, the conduction period of each SCR is, for highly inductive load, what is the duration of conduction for each SCR? 120 degree. In three-phase full wave fully controlled bridge converter, the natural commutation instant for a thyristor connected to the highest positive phase voltage occurs at what angle with respect to phase voltage? Three-phase full wave fully controlled natural commutation for a thyristor connected to highest positive phase voltage to highest positive phase voltage. का नेचुरल कम्यूटेशन एक थायरिस्टर 120 डिग्री के लिए कंडक्ट करता है. लैंग ऐसा कह दो 30 डिग्री लाइक when you see positive group common cathode. Okay, it is like a similar to half wave rectifier. Even comes at 30 plus alpha, or you can say 30 degree later than the instant when TAN becomes positive. TAN becomes positive at 0 degree, but T1 conducts at 30 degree. AN तो 0 डिग्री पे पॉजिटिव हो गया, बट T1 30 डिग्री पे आपका फॉरवर्ड बायस होगा, सो द गैप इज 30 डिग्री. चलिए, एवरेज आउटपुट वोल्टेज फॉर अ फुल कन्वर्टर विद अल्फा इक्वल टू 0. ठीक है, एवरेज आउटपुट वोल्टेज फॉर फुल कन्वर्टर विद अल्फा इक्वल टू 0 बताइए. 3 VML by pi. Okay, because it is 3 VML by pi cos alpha. If alpha is 0, it is 3 VML by pi. For a three-phase full converter with continuous conduction and firing angle alpha, FDF at the input side is continuous conduction. Beta, for a three-phase full converter, what is FDF? Cos alpha. Full converter cos alpha, semi converter alpha by 2. Boundary between continuous and discontinuous conduction for a three-phase full converter with a R load is at a firing angle alpha of. बाउंड्री क्या होगी कॉन्टिन्यूस और डिसकॉन्टिन्यूस की एट अ फायरिंग एंगल अल्फा. फॉर फुल कन्वर्टर इट इज 60 डिग्री. फॉर हाफ वेव is 30 degree. In three-phase full converter, if firing angle is increased beyond 90 degree, V0 average becomes negative. It is essential for which mode of operation? कौन से ऑपरेशन के लिए, कौन से मोड ऑफ ऑपरेशन के लिए V0 का नेगेटिव होना जरूरी है? फिफ्थ रिपीट कर दूं बेटा, एफडीएफ आपका थ्री फेज हो या सिंगल फेज, फुल कन्वर्टर के लिए कॉस अल्फा होता है, सेमी के लिए कॉस अल्फा बाय 2 आता है. ठीक है, बस यही तो है इसमें इन्वर्जन. V naught negative is important for inversion, not for rectification. चलिए next. Which are the characteristic of the input current waveform of a three-phase fully controlled converter with a highly inductive load? Highly inductive load के लिए बताइए. बोलो भाई. It is a quasi square wave. Fundamental component is in phase with the source voltage. No, the angle is cos alpha. So angle is alpha. RMS is I naught root 2 by 3. सप्लाई करंट बेटा साइनोसोइडल थोड़ी होता है, क्वाजी स्क्वायर वेव होता है. सप्लाई करंट हैज हार्मोनिक्स. चलिए नेक्स्ट. A three-phase half-wave converter has a common cathode configuration. Which statements are true? For common cathode beta. For common cathode, which statements are true? SCR with the most positive anode voltage will conduct. PIV is root 3 Vm, that is VML. है ना, root 3 Vm is VML. It produces a higher ripple frequency compared to a full wave bridge. No, because for half wave beta, ripple frequency is 3f. For bridge, f naught is 6f. It causes DC magnetization, yes, because supply average current is non-zero. जैसे फुल वेव रेक्टिफायर में बेटा व्हाट वाज हैपनिंग, आई वाज गेटिंग 120 डिग्री करंट वाज पॉजिटिव, फॉर 120 इट वाज नेगेटिव, तो एवरेज विल बी जीरो. बट इन अ हाफ वेव कन्वर्टर you will only get the positive part, not the negative part. हाफ वेव रेक्टिफायर में सिर्फ आपको सप्लाई के करंट में वो 120 डिग्री का पॉजिटिव मिलेगा, नेगेटिव मिलेगा ही नहीं. तो एवरेज विल बी नॉन जीरो, देयरफॉर इट विल कॉज सैचुरेशन. चलिए, कंपेयर टू अ थ्री फेज फुल कन्वर्टर, अ थ्री फेज सेमी कन्वर्टर. देखो ये वाला आप लोग कल कर पाओगे, but semi converter cannot produce negative output. No, it has better power factor. Yes, it uses thyristor and diode. Yes, it has a freewheeling period. Yes, it is a semi converter, तो freewheeling action भी होगा, power factor भी बेहतर होगा, और semi है इसका मतलब all devices cannot be controlled. Some are thyristor, some are diodes. चलिए ट्राई कीजिए. The range of firing angle for a three-phase three-pulse converter. Three pulse माने half-wave rectifier feeding a resistive load is क्या आ रहा है भाई 30 to 150? गलत, ये कंडक्शन का रेंज है, आंसर इज 0 to 150। देखो this was the situation. Now this was from 30 plus alpha to 150 plus alpha. Now we can conduct or we can trigger SCR only during positive half cycle. Therefore 30 plus alpha should be less than 180 because sign after 180 becomes negative. साइन की 180 के बाद नेगेटिव हाफ साइकिल चालू हो जाती है, तो यू हैव टू कीप अल्फा लेस देन 150 डिग्री। अल्फा को 150 से कम ही रखिए, तो आंसर इज बी। चलिए ट्राई दिस वन। 3 पल्स कन्वर्टर सप्लाइड फ्रॉम आइडियल ट्रांसफॉर्मर इज having a load current I naught which is ripple free. I want to know the triggering angle such that freewheeling diode conducts each time for same duration as SCR, then the ratio of the RMS current. देखिए, without freewheeling diode, it is a 3-phase half wave rectifier. So each SCR conducts for 120 degree. Now it says gamma freewheeling diode is equal to gamma SCR in each pulse. So that means both are equally sharing the conduction. So total gamma freewheeling diode will be 180 degree. टोटल कितना आ जाएगा बेटा? 180 डिग्री। एंड गामा SCR विल रिमेन 60। सर क्यों बेटा? क्योंकि 3 अलग अलग SCR हैं, बट तीनों पल्सेस में फ्री व्हीलिंग डायोड एक ही है। In all the 3 pulses, same freewheeling diode conduct, but if I talk about SCR, there are 3 different SCR. So IFD RMS, I naught root 180 by 360, so I naught by root 2, I thyristor RMS, I naught root 60 by 360, I naught by root 6. समझ में आया लॉजिक? The question says every time freewheeling diode has to conduct for same duration as SCR. ये half controlled bridge है बेटा. This you will understand tomorrow. ये अभी मैं नहीं करा रहा हूं. चलो next बेटा. Let me tell you one thing. Again बेटा, it is a case of source inductance. ये वाला क्वेश्चन भी कल होगा, बट लेट मी टेल यू वन थिंग. फायरिंग एडवांस एंगल is actually 180 minus alpha. It is used in the inversion mode when rectifier acts as a inverter. चलिए try this बेटा. Source current when the firing advance angle is 60 degree. You need the source current. 3-phase full converter is there. Firing advance angle is 60 degree. Which means बेटा ये भी मैं करा देता हूं. चलो अभी थोड़ी दिक्कत आएगी. 180 minus alpha is 60. So alpha is actually 120 degree. Okay. Sir, why not V naught minus E by R? In inversion mode, listen to this carefully. This also I will tell you tomorrow. अल्फा ग्रेटर देन 90, E is connected with opposite polarity. ईएमएफ जो कनेक्ट किया जाता है ना, वो उल्टी पोलैरिटी के साथ करते हैं, ठीक है। तो इसीलिए माइनस ई की जगह प्लस ई होता है। ऐसा क्यों करते हैं मैं आपको कल बताऊंगा। वाई डू यू कनेक्ट ई विद द अपोजिट पोलैरिटी। नाउ बेटा, बाय डिफॉल्ट द वोल्टेज 400 is to be taken as RMS line to line value। बाय डिफॉल्ट उसको RMS लाइन टू लाइन वैल्यू मानना। एट एम्पियर। नाउ इट इज आस्किंग द सोर्स करंट। This is the case of a full converter. A source current IS RMS हुआ 6.52। Okay. ये वाले क्वेश्चन मैं कल के लेक्चर में ऐड कर दूंगा। okay. चलो ये वाला ट्राई करो बेटा। RMS वैल्यू ऑफ AC लाइन करंट, RMS वैल्यू ऑफ AC लाइन करंट, इसको ट्राई करो। देखो भाई, इट इज वेरी सिंपल। सप्लाई करंट RMS is I0 √2/3। I0 is given as 100। okay, 81.65। okay, next try this beta। The output voltage at the rectifier terminals when the voltage of A phase is maximum। जब A phase का वोल्टेज पीक पे होता है, उस समय आउटपुट पे कितना वोल्टेज आएगा। तो बेसिकली आई एम आस्किंग यू द इंस्टेंटेनियस वैल्यू, यानी कि वेव फॉर्म का उस मोमेंट पे वैल्यू मांग रहा हूं जहां पे आपका ए फेज का वोल्टेज मैक्सिमम है। करिए। देखो देखें, देखिए, we take VAB as reference. Now, if I talk about VAN, it will lag the phase voltage by 30 degree. ठीक है? So, it will be maximum at omega t equal to 120. 120 पे maximum आएगा. Now, V0 is VAN. From 60 plus alpha to 120 plus alpha. Now, what it has given is, alpha is not given. Sixty to 120. So at 120, when A phase voltage is maximum, it is VML sine 120. Root 3 VM sine 120 is 3 root 3 by 2, 1.5 VM. 1.5 VM. Okay. So the answer is 1.5 VM. भले ही इसने देखो an को रेफरेंस दिया, बट मैं जो पढ़ के आया हूं मैंने ab को रेफरेंस माना है, मैंने वहीं से सॉल्व किया, बिकॉज द एसेंस ऑफ क्वेश्चन डज नॉट लाई इन द फैक्ट which voltage is maximum, or sorry, which voltage is reference. The question statement mainly says when the voltage of A phase is maximum, at that point what is V0. जब A phase का वोल्टेज मैक्सिमम जाता है तब V0 कितना आता है. चलिए, now try this. Now try this. A three-phase full converter is being used to charge a battery of EMF 100 volt and resistance 0.25 ohm. Charging current is 12 ampere when AC line voltage is 220. Now you want to transfer the energy from DC source to three-phase. That means it should act as an inverter. Then alpha is 160. What is AC line voltage for same DC value of source current? That is 12 ampere. हाँ भाई देखें, तो फर्स्ट ऑफ ऑल बेटा, you are saying now you are delivering energy from the battery to the source. So remember to reverse the EMF. Rather than 100, use minus 100. Current is 12, resistance is 0.25. Minus 97. ठीक है? It is 3 VML by pi cos alpha. Alpha is given to me as 60 degree. So minus 97 pi by 3 cos 160. So cos 160 will be negative, so it will become positive. 97 pi by 3 cos 160. 95.45. So VL is peak voltage by root 2. 67.49. ये आ रहा 67.49 आ रहा यार, ठीक है, द आंसर शुड बी 67.49. Now I will come to the assignment of lecture number 5. In the circuit shown, the diode is ideal. What is the power factor? Now beta, for R load, input power factor is very simple. P naught RMS by PS RMS. ये R load में चल जाता है हमेशा. Now because it is a diode, P naught RMS, half wave rectifier Vm by 2, PS RMS is Vm by root 2. Because input is sinusoidal, na, but output is a half wave rectified sine wave. So it is 0.707. And remember, power factor of rectifier is always lagging. Rectifier का power factor हमेशा lagging आता है. PS is 120 volt 60 hertz. L and E is given the instant where the load current extinguishes. Now beta, conduction starts at theta, sine inverse E by Vm. Now E is 150, Vm will be 120 root 2. (62.11 degree). Now what I will say, L di by dt, m sin omega t minus E, m sin omega t minus E d omega t. Now at theta the conduction starts, current is 0. At omega t it is I. So integration of LHS is I cos theta minus cos omega t minus E omega t minus theta to pi by 1/8. Now what you have to do beta, at omega t equal to beta, current should be 0. cos 62.11 minus cos beta equal to 150 beta minus 62.11 pi by 180. Now you have to check options. क्योंकि इक्वेशन तो आप सॉल्व नहीं कर पाओगे बेटा. यू कैन नॉट सॉल्व दिस. बीटा इज कमिंग इनसाइड कॉस एंड आउटसाइड कॉस. चलिए लेट मी चेक. I will write 120 root 2 cos 62.11 okay. So first I am writing 146.68. It is minus 0.21. Then I am writing 225. It is 227. Then I am writing 135.67. It is 8.2. Then I am writing 218 minus 5. से कोई लेना देना हमें बता. None of these आ रहा है यार इसमें से. तो कोई भी ऑप्शन सेट नहीं हो रहा है. चलो नेक्स्ट. रेफरिंग टू द फिगर, व्हाट इज द टाइप ऑफ लोड? It is DC motor load because beta this line will be E and output goes below E. So it can be RLE. In RE load ना the output never goes below E. अगर RE load होता है तो E के नीचे कभी जाता ही नहीं है. A thyristor converter feeding a resistor R, power consumed by resistor in absence of thyristor is P. Power consumed by resistor at alpha equal to pi by 2. Now in a resistive load with a with a half wave rectifier, it is 1 by 2 pi minus alpha plus half sin 2 alpha. ठीक है. Sin 2 alpha will be 0. Now pi minus alpha will be pi by 2 by 2 pi 1 by 4. So outside the root you will get half Pm by 2. without SCR, the peak value will be Vm by root 2. For sinusoid. So P dash will be P by 2. It will become half. पाई होता है हाफ वेव P. Okay, so answer is 1 by 4. एक्चुअल एंगल बेटा निकालना पड़ेगा. कैसे निकालना पड़ेगा? न्यूटन राफ्सन मेथड से. Half wave rectifier is supplying a load of impedance 8 ohm at alpha 60. Effective value of voltage. Effective value of voltage is V not RMS. Now I am taking it as a R load because nothing is mentioned about the nature of the load. So I am taking the impedance as resistive. And beta same RMS is applicable to a full wave rectifier, but instead of 4 pi you will get 2 pi. यही फॉर्मूला लगता है फुल वेव में भी आर लोड के अंदर. बट वहां पे आपको क्या मिलता है? वहां पे आपको मिलता है नीचे में 2 पाई. टू पाई बाय 3 प्लस रूट 3 बाय 4. 139.53. That is 140. Okay, so it is 140. Is that clear? इनपुट फ्रीक्वेंसी अगर 100 हर्ट्ज है तो हाफ वेव रेक्टिफायर की आउटपुट फ्रीक्वेंसी भी 100 हर्ट्ज होगी. उसी को रिपल फ्रीक्वेंसी कहते हैं. For the given half wave rectifier circuit, internal resistance of diode is 20, RL is 1 kilo ohm. Input is a AC with RMS of 110, DC value of voltage across the diode. ठीक है. Voltage across diode during positive half cycle. It is forward bias. Then it is beta. Em sin omega t. Use the voltage division 20 by 1020. Okay, because diode resistance is 20. And during negative half cycle, diode is off. So the diode voltage is fully Em sin omega t. So Vd average Em by 51 sin omega t omega t. Okay, then pi to 2 pi full supply voltage Vm sin omega t t omega t. So take Vm common. One by 51 minus. What is Vm? 110 root 2. .54. Okay, so in the positive half cycle, the voltage will be negligible. बहुत कम वोल्टेज आता है पॉजिटिव हाफ साइकिल में. वेरी गुड बेटा. अल्फा इज 60, एवरेज पावर एंड पावर फैक्टर. और आर लोड बेटा अल्फा इज 60, so 1.5 पापा. now V naught RMS कितना आएगा 1/4 पाई. .4484. So Vn is 120 volt. आ रहा है 76.1. What is this? 40.5. Now beta power factor, I told you for R load it is very easy. .1 upon 57.91. 76.1 by 120. 0.634. 0.634. Okay. चलो. A single phase 221 kilowatt heater half wave controlled rectifier. ये क्वेश्चन अभी हमने किया था ना. Same as question 4. P dash will be P by 4. बस यहाँ पे वैल्यूज दे रखी हैं बेटा. वैल्यूज दे हैव गिवन. Ripple factor of the output rectified wave. Ripple factor means THD. आउटपुट वेव का ना TRF. V naught RMS sin 180 will be 0 pi by 2. V naught average. Okay. Pm by 2 pi 1 plus cos alpha. Cos 90 is 0. Form factor is RMS by average. Okay. So it is 2 root 2, 2 pi by 2 root 2 pi by root 2. form factor square minus 1. B. Answer will be B. Okay. ये आ गया form factor square minus 1. Average output voltage is 25% of the maximum. Maximum occurs at alpha equal to 0. So 0.25 of maximum is the average output voltage for R load. For R load in a half wave rectifier, if you want, you can remember average and RMS. Okay? And RMS and average for full wave rectifier. Average will be double. RMS will contain 2 pi inside the root rather than 4 pi. RMS में क्या आएगा? अंदर में 2 pi आ जाएगा 4 pi की जगह. Now, thyristor is always gated in the positive half cycle. Now, average value is 100. So, V0 is 20. Now, this is same as that of a R load. Freewheeling diode gives you the same functionality as R load. ठीक है? Highly inductive load with a freewheeling diode gives me the same functionality as a R load. $122.24. Very good, Subhadeep. Very good, Ronak. Now, single phase thyristor converter supply voltage alpha. Not average is Vm by 2 pi 1 plus cos alpha. √2 by 2 pi. .8837. Okay. Okay. $155.07. Now supply RMS current is same as output RMS 1.5507. Now form factor is 155.07 by 88.37. $1.442. Very good, Subhadeep and Ronak. One pulse SCR converter is triggered at alpha equal to 40, beta is 210. Circuit turn off time 2 pi minus beta by omega, because forward biasing occurs at 0 degree then 360 degree. ठीक है? So next forward biasing at 360. by omega 150 by 180 into 100. 5 by 6 into 100. 8.33 millisecond. V naught average. Now beta you have to go by basic. Integration of sine is minus cos. I naught will be V naught by R because inductor does not play any role in the average value. इंडक्टर का एवरेज में कोई रोल ही नहीं है, ठीक है। एवरेज मेरा गड़बड़ आ रहा है, अरे यार मैंने पाई की जगह पाई ले ली, आ रहा है 84.49 आ रहा होगा। Freewheeling diode decreases the possibility of discontinuous conduction. It improves continuity. है ना, continuity को बेहतर बनाता है and improves the power factor also. ठीक है, improves the power factor. एवरेज चार्जिंग, एवरेज पावर, ठीक है, ये मैं आप ही लोगों के लिए छोड़ रहा हूं। सिमिलर क्वेश्चन इज डन इन क्लास। किया था ना, यहां पे एवरेज और आरएमएस निकालना पड़ेगा। और बैटरी ना बेटा, मोस्टली दे विल आस्क यू द एवरेज करेंट। In these question, in the subjective questions, they might ask you RMS current, but practically speaking, in the exam, they will only ask you the average current. Okay. Now tomorrow, beta 1 minus form factor square नहीं होता, form factor square -1 होता है अनुज। Now tomorrow we will complete the rectifiers, and then day after tomorrow, Wednesday, we will have a PYQ session on rectifier and the devices. Okay. So I'll see you all tomorrow. Have a great day everybody. और YouTube वाले बच्चों के लिए बेटा आज लास्ट डे ऑफर का फॉर 70% डिस्काउंट ऑन द RIB एंड द कॉम्प्रिहेंसिव गेट 2026 बैचेस। फॉर गेट 27 इफ यू वांट टू परचेज द न्यूली लॉन्च रिकॉर्डेड कोर्सेज, आपको EB30 कोड लगाना है, 30% ऑफ मिलेगा। बाकी गेट 26 के कोर्सेज पे 70% ऑफ यूजिंग द कोड YT70 and test series also 70% off using the code Ankit ESE. न्यूमेरिकल्स में प्रॉब्लम आ रही है बेटा, तो प्रैक्टिस आपको ज्यादा करना पड़ेगा। अपने नोट्स सामने रख के प्रैक्टिस कीजिए और धीरे धीरे आपको ये कॉन्सेप्ट याद रहने लगेंगे, ठीक है।